Completing the square is the first part of Chapter 7, and Chapter 7 is all about quadratic functions. So, quadratic function looks like f of x is equal to something times an x squared plus something times an x plus another something. And we've done a good job this year of talking about the family names of different kinds of functions. So, this is what we would call a quadratic function, or we'll just call it a quadratic for short. Just realize that quadratic is an adjective and function's a noun. So if I say a quadratic, I'm not being terribly good with my English, but we'll get over it. So f of x, if I'd use g of x and say g of x is equal to, let's make like a root 2x
plus a 5. We dealt with that in the last section with radicals, but that is really a linear function, so it's not what we're dealing with. Now, the first kind of skill we're going to do, and today's just entirely a skill, is on solving a quadratic equation. So a quadratic equation, whereas above we had a quadratic function. A quadratic equation is just a quadratic set equal to something. So let's just do an example of what this looks like. If I wanted to solve 0 is equal to x minus 1 squared minus 4, that's a quadratic equation. And I know that because its largest degree right here would be a degree 2. So what I'm going to do with this is, you guys might think we want to multiply that all out, but really it's actually easiest just to add 4 to both sides. You get 4 is equal to x minus 1 squared. Then we do an operation to both sides to undo the square. We're going to do the square root of 4 is equal to the square root of x minus 1 squared. On the left side I get a 2, and the right side I get the absolute value of x minus 1. Remember, the square root of square is an absolute value, which means that x minus 1 is really equal to positive or negative 2. Now, we're mostly going to skip that step. Just go right to x minus 1 is equal to plus or minus 2. Then I'm going to add 1 to both sides, and I get x is equal to 1 plus or minus 2. Don't leave that. 1 plus 2 is 3, and 1 minus 2 is negative 1, and those would be our two solutions. I know there would be two solutions because it's a quadratic. And quadratic implies that there will be two solutions always. That's the fundamental theorem of algebra. A polynomial of degree n has n solutions, so this is a polynomial of degree 2. It should have two solutions. Next problem, x squared minus 6x plus 2 equals 0. If you look at this, before the way we would solve this would be by factoring. Well, I cannot factor this. I can't factor it because the 2 can't, you can't get from 2 to 6 by splitting that up and adding. So what we have to do is we have to use a skill that we're going to introduce here. This is the topic heading called complete the square. Which means I'm going to look at the x squared and the negative 6x and decide I want to group those together and kind of keep everything else a little bit separated. So we're going to have it be x squared minus 6x, and I'm going to move the 2 over to the other side. And let me check the recording just a second. Okay, looks good. Doing what it needs to. Okay, then we go x minus 2 minus 6x. What I'm going to now do is add something to both sides. So this is a new step right here. I'm going to add a box to the left side, and then the right side I'm going to do a negative 2 plus another box. My question is, what needs to go into this box that would make this polynomial on the left side become a perfect square? So I've seen this done a couple of ways. I basically want to say, this is one of my favorites. If I take this like this and I factor it as a square, I'm going to kind of take this 6x and say, well, what does this need to be in order to add to itself to get to 6? That should be a minus 3 minus 3. That's the only way to get to a negative 6x if it's itself, if it's x minus 3, x minus 3. In other words, I'm trying to come up with a binomial squared that makes that middle term become 6x. And that has to be minus 3 minus 3. It's the only way to split this up. But if I do x minus 3 squared, the last term would be a 9. Well, that means I added a 9 to the left. I must also add it to the right. And then on the left side, I'm actually going to factor that as x minus 3 squared equals a 7. Add the negative 2 and the 9. Now I'm going to take the plus or minus square root and get x minus 3 is equal to plus or minus radical 7. Add 3 to both sides, and I get x is equal to 3 plus or minus root 7. This represents two solutions. And when we do set notation, we're going to put them as the plus or minus, but those are two possibilities, and these are called the exact solutions. If I ask for the approximate solutions, it means I want you to take out your calculator and do 3 plus root 7, which will give you about 5.65, and 3 minus root 7, which will give you about 0.35. That's what we call the approximate solutions. Usually your directions will ask you for the exact solutions, but it's useful to know the approximate solutions would help you if you're doing any sort of science work where you want to measure something. So let's do another one. X squared plus x minus 15 equals 0. And we want to solve this. Well, if I put the 15 over to the other side, I get x squared plus x equals 15. Then I want to add something to both sides. And what I'm adding, and this is going to be a little bit tricky, but I want to split this up, and I want to get a number that when I add it to itself, I get 1. So a number that when I add it to itself, I get 1, because 1 is the middle coefficient there. Well, the only number that adds to itself to get 1 is 1/2. And then 1/2 times 1/2 would be 1/4. So on the left side, this is going to factor into x plus the square root of 1/4 is 1/2 squared equals, and then I need to do 15 plus a fourth. Well, 15 plus a fourth is 61/4. Then take the plus or minus square root of both sides. We get plus or minus root 61 over the square root of 4 is 2. And if I subtract 1/2 from both sides, I get x is equal to negative 1/2 plus or minus root 61 over 2, which is better expressed like this, all over 2. Negative 1 plus or minus root 61 all over 2. And that's going to be my two exact solutions. Now, there's a quick way to get that number that we ended up adding. I want to go back to number 2 and look at this number right here, this negative 6. If I look at that negative 6 and I take half of negative 6 and then I square it, that gives me this number that I'm going to stick in right there. So half of negative 6 is negative 3, and negative 3 squared is 9. So that means I need to add 9 to both sides. If I go here and I do the same thing with this, sorry, not with the 1/4, with the visible 1 that's just sitting right here. So let's get the 1. Kind of just take a glance at it. Half of 1, so look at what half of 1 is, and then I square that. So half of 1 is a half, squared is a fourth, and that's going to be the number that we end up adding. So let's try that with another example. Let's find the zeros of f of x equals 2x squared plus 8x plus 11. Remember that zeros mean the same thing as roots, x-intercepts. They all mean kind of the exact same thing. It means we plug in 0 for y. So I go 0 is equal to 2x squared plus 8x plus 11. So I want to again group the 2x and 8x, 2x squared and 8x by itself. So we're going to make this 2x squared plus 8x equals negative 11. Now my trick of doing half the middle term and squaring it only works if my leading coefficient is a 1. So I want to divide both sides by a 2. X squared plus 4x equals negative 11 halves. Then I'm going to do the step where I add something to both sides. X squared plus 4x plus something is equal to negative 11 halves plus something. So we're going to look at this, and I'm going to say, okay, what is half of 4 and then squared. Well, half of 4 is 2, and 2 squared is 4. So we're going to add 4 to both sides. Left side. Oops, didn't mean to write that there. Right side. And I get x plus 2 squared when I factor the left side equals 4 is really 8 halves, so 8 halves minus 11 halves is negative 3 halves. We're going to take the plus or minus square root. X plus 2 is equal to plus or minus radical negative 3 halves. Now the very first thing you should do when you see that radical negative is pull out the I. So radical 3 halves I, kind of off to the right side. Now, before I kind of subtract the 2 over, I want to rationalize radical 3 halves is the same as radical 3 over radical 2. So if I do radical 3 over radical 2 and I multiply it by root 2 over root 2, still have the I off to the side, that's going to give me x plus 2 is equal to plus or minus root 6 over 2, I. Then all I need to do is subtract the 2 over, so x is equal to negative 2 plus or minus root 6 over 2, I. That gives me my two solutions. These happen to be complex solutions, complex numbers, but they are my two solutions. Do not add the negative 2 and the negative 6 over, or root 6 over 2, because I want to keep this in a plus bi format since it is a complex number. So we're going to keep this as it is. If it's just a straight up radical, we would add them, but this is not. Okay. Let's do another example. This one with just a decimal in the leading coefficient. 0 is equal to 0.5x squared minus 4x minus 8. Well, 0.5 is kind of a stupid number, and if we multiply the left and right sides by a 2, I can just clear that right away and make it x squared minus 8x minus 16. I want to move the 16 over to the left side. 16 is equal to x squared minus 8x. I want to take half of 8, half of negative 8, square it. That's going to be meaning I need to add 16 to both sides. So we're going to do plus a 16 plus a 16. That's the number that we add. Left side becomes 32. Right side factors into x minus 4 quantity squared. Now I'm going to take a plus or minus square root, so plus or minus root 32 is equal to x minus 4. And I get plus or minus 4 root 2 is equal to x minus 4, or x is equal to 4 plus or minus 4 root 2. Do not write it as plus or minus 4 root 2, plus 4. Don't write it like that. We kind of always put something in front of the plus or minus. It looks cleaner and it's a little bit easier to evaluate. So those are my two solutions. Lastly, I want to do this process when I just have variables. So let's say that I have 0 is equal to ax squared plus bx plus c. And I want to do this for any a, b, and c. Well, the trick was we need to subtract the c to the other side, so I get negative c is equal to ax squared plus bx. I don't like having a leading coefficient, so I want to divide by the a to get negative c over a is equal to x squared plus b over a x. The trick, the thing that we needed to add to both sides to complete the square was we needed to do half of the middle term squared. So I'm going to do half of b over a and then square it. And that's what I'm going to add to both sides. Well, that's the same as b over 2a squared, which is the same as b squared over 4a squared. So I'm going to add a b squared over 4a squared to the left side, or right side, and b squared over 4a squared to the left side. This looks complicated, I know, but it should make sense about what I added to the left side and the right side. It was half of the b over a and then squared. Okay, now we're going to factor the right side. This is going to factor as a perfect square. We set it up that way. So this is going to be x plus the square root of b squared over 4a squared is just b over 2a squared. the left side I need to add with a common denominator of 4a squared. Well, the b squared is already over the 4a squared, but the c is not. It needs a 4a, so I'm going to subtract 4ac all over 4a squared. Now we're going to do a plus minus square root, so left side becomes plus or minus radical b squared minus 4ac over, I can actually take the square root of 4a squared and make it just 2a equals, I got x plus a b over 2a. And if I subtract b over 2a and put that at the start, I get negative b over 2a plus or minus root b squared minus 4ac over 2a equals x. And if I put that all over the same denominator, I just get x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. I'm curious at what point some of you realized where I was going with this, because all of you should be able to look at that equation and recognize it and see that it actually came from this, just from a logical method of moving all the variables around and getting the x by itself. But we could not have done that if we had not known how to complete the square. Okay, that's it for the video. Please check the calendar for the homework for tonight, and we will see you later.